Hi again, Pre-Calcers. Time for another online lesson. Today 3-4, inverse functions and relations. Now this word inverse actually has several meanings, it seems like. What do you think would be the appropriate definition of inverse in this chapter? You can take a look at these definitions, which are all definitions of inverse. Take a look at this guy, pause a moment, see what you can come up with. The correct one, actually, in this case, is letter, drum roll please, once I figure out my pen situation here, is letter A, flip. Just like our nature of our course, the flip classroom, if you think of inverses as a flip, that will be good. Now, we'll go on to the next, what that means here a little bit. You probably remember from your intermediate algebra days, if we're trying to find the inverse of that particular function, all we have to do is flip the x and y's. So again, sometimes the inverse is designated with a -1 power like that. And if I write down these ordered pairs, it would simply be 3, -2. If I can write a negative sign there. 7, -1. -2, 0, and 3, 6. So that's pretty easy, just reversing or flipping the x's and y's. Now it gets just a little trickier when we get to actual functions here. Can I find the name of the inverse function for this f of x equals 2x minus 7? Well, we start out by writing it as y equals 2x minus 7. And then here's where the flipping comes in. We're going to actually interchange the x and y variable, just like we did in the above example. And then we're going to go back and try to solve for y again. So, when I write it, it's actually going to be x equals 2y minus 7. I want to solve for y, so I'm going to add 7 to each side, like this. And then, of course, I need to divide by 2. So my final answer then, which I could write as f to the -1 power of x, so that's going to be x plus 7 over 2. So that's a good way to find the equation of an inverse function. However, we won't be able to do that with every one that we encounter just because of the complexity of the equation that we have, but that's always a good practice to be able to do, and you'll eventually. Now, a couple helpful visuals here to make sense of these inverse functions. We have this thing called the horizontal line test. What that means, we're familiar, of course, with the vertical line test that determines whether a relation is a function. But the horizontal line test will tell us whether the inverse of a function is a function. And so we're going to pass horizontal lines through these things, and if it goes through at most one point or only one point, then we know that its inverse is also a function. So actually in this first example here, this one isn't even a function, so kind of dumb. This one here is a function. Will its inverse be a function? Well, notice when we pass a horizontal line through there, it does cross more than once. So the inverse for this one will not be a function. Same thing with our bottom example here. This one is a function, but its inverse is not. If we look at graph 4, though, we see that that is a function, and clearly when I pass a horizontal line anywhere here, it's only going to cross once. So graph 4 is the only example here that is a function. We take its inverse, and its inverse will still be a function as well. Another kind of nice visual, and this helps us primarily in graphing here. When you graph a function and its inverse, they will always be symmetric with the line y equals x. Symmetric with the line y equals x. So here you see a couple examples here. On the one on the left we have f of x equals x to the 3rd power, and its inverse is x to the 1/3. You can see how each of those are graphed, and then how it is going to be symmetric with this line y equals x. You fold it over that line, fold onto itself. Same thing over here in this example. y equals e to the x, y equals the natural log of x. That's a famous function. Those are also inverses. We can tell because they are symmetric with that line y equals x. Now here's a good type of problem here. Find the inverse of that function, x squared minus 4, which I have graphed right here, and graph both the function and its inverse. Well, is this one that we can find the inverse of? Yeah, it is. First of all, let's see if we can solve this. As we said before, remember this is the function, or I can write it y equals x squared minus 4. I want to do that flipping or reversing of my x and y. So now I have x equals y squared minus 4 like that. Can I solve this for y? Yeah, I should be able to. So again, I'm going to add 4 to each side to get that y by itself. So I have y squared here. Now here's where it gets a little tricky. I do have to try to solve this for y. So I'm going to take the square root of each side. And notice I can't really do much more than this. I just have to write it as the square root of x minus 4. And I write it like that. Now, you might remember from our earlier talk in this chapter, what will this particular function look like? Well, that square root function, you might remember, started at the origin and kind of shot off like this. The plus 4 is actually going to move this 4 units to the left. So the way this is actually going to be graphed would look similar to this. Now, the one thing you got to watch out for, though, is whenever you take a square root, the other thing that you should always do is make sure to put a negative sign in front of this. Also graph this. Also realize that this is going to be part of the function. And so the opposite of this, or negative, will just flip this over the x-axis like this, and then it should be graphed like that. Okay, so that's kind of tricky, those kind of things there. And here I've showed you how to do that on your graphing calculator. There's my original function here, of course, the x squared minus 4. We showed you how to do the inverse. Here's what each of those look like. So whenever you have any square rooting to do to be able to find an inverse, make sure to include both the positive and the negative portions of that to get a correct graph. Getting back to what we talked about earlier, clearly this is a function, x squared minus 4, but because of that horizontal line test, my inverse will not be a function, which we can clearly see. All right, here's another example here, and okay, I'm back here. So this is the function. Let me get this set up here. This is going to be y equals x squared plus 6x plus 4. Now you can see the problem here. If I try to switch my x's and y's here, it's going to be a bit of a pain because I'm going to have a y squared and a y. How do you solve for that? So that's kind of tricky. The directions on this kind of problem would simply be to graph the function and graph its inverse. So here's what I'd encourage you to do. Go ahead and enter this in your calculator as I have here. And you see, of course, it's a parabola. It's an x squared. And then take a look at the table. And so when I look at the table, then I can generate some ordered pairs here. Now, after that, I'm going to try to graph some of these ordered pairs, but remember when I graph the inverse, I'm just going to flip-flop my x's and y's. So for instance, I would have the ordered pair -5, -3. So that would be about here. And then I'd have -2, -4, which would be about here. And -1, -1. Excuse me, so -3, excuse me, -4, I'm getting a little mixed up here, -4, -2, -1, -1, 0, 4, or 4, 0, excuse me. So it's going to look something like this, I think you can see. And then as I get to be my more positive numbers, I'm going to get that. My bottom part will look something like this. Kind of a bad sketch there, but you get the idea. The general principle here, even though I was stumbling and fumbling around there, is graph the original, take a look at the table, and then when you plot the points, then do your inverseness. In other words, flip the x and the y to do that. Alright, thanks for watching everybody. We'll see you guys in class, and take care.